The winner of the 2014 3-minute thesis People's Choice Award was Arun Shrivats. In your presentation, you'll want to give your audience a clear entry point into a subject they don't know much about. In this case, your entry point will be the 4 novelty moves. We'll highlight in this clip how Arun uses the novelty moves, as well as vivid metaphors and transitions, to give a clear picture of his project.
Our bodies exist in a perfect state of balance called homeostasis, and the bone tissue in our skeleton is a really great example of this. You don't see or feel it, but at any moment in time, 3 to 5% of our bone mass is being absorbed and reproduced simultaneously. Now this is a delicate balance. It can be disrupted by a rare condition called fibrodysplasia ossificans progressiva, or FOP. FOP patients have a genetic mutation that causes the stem cells in their muscles, tendons, and ligaments to start producing bone. The end result is seen in this central figure here, which clearly is a far cry from what you see in a normal, healthy human skeleton. As you would imagine, FOP is severely debilitating. Most patients are in a wheelchair by their 20s and are dead by their 40s.
The significance here is that this disease is severely debilitating, resulting in an early death. The central figure he refers to is another way to show this significance, and it's also a great use of images to get across a very stark point.
At this time, there's no cure for FOP. There are no effective treatment options.
Now here's a case where the status quo is a gap. The current practices are that no solution exists. The phrase, "at this time," is a great signal to establish the status quo. And then he clearly marks where the gap is by saying there is no cure, no treatment options.
Together with my team, I'm trying to change this. But where do you even start with a disease like this? Well, what we did was we began with the stem cells responsible for this bone formation.
Here's where Arun details how he's going to fill this gap. He's trying to change the status quo and provide a treatment option, beginning with the stem cells responsible for this bone formation. Later, he'll get into more detail about how he's doing this, but the key phrases, "I'm trying to change this," and "but where do you even start?" are great transitions to let the audience know he's moving from identifying the gap to filling it.
Now, the cells of our body are in many ways like tiny little computers. Now, all computers have keyboards or inputs, and for our cells, their keyboard is comprised of what are called cell receptors. Because of the FOP mutation, what happens with one of these receptors is that once it's activated, it gets stuck in this on or activated position. It's a lot like if you press the B button on your laptop, but instead of one B showing up on your computer screen, you just get this never-ending string of Bs, continuous, all the while stimulating bone formation from these cells.
Let's stop here to notice this effective use of metaphor. It works partly because he picks one metaphor and sticks with it from the big picture concept, cells are computers, to the nitty-gritty details. FOP happens when an input gets stuck like a button on a keyboard. It also works because it's so accessible to daily life. A key part of 3MT is using language that a non-specialist audience can understand. Metaphors and analogies from daily life are a great way to aid comprehension.
So how do we stop this from happening? Well, my approach is that we silence the crucial bone formation genes in these FOP patients. I accomplish this by delivering siRNAs, or short interfering ribonucleic acids, to the stem cells of these patients. Now, the siRNAs, which are shown in green up here, are structurally very similar to DNA, but they're much smaller. The most important part about them, though, is that when delivered to cells, what they do is they silence active genes that have matching genetic sequences. So, in the context of FOP, by silencing the right genes, it doesn't matter that this B button is getting stuck because we're silencing the key genes required for bone formation. Now, a big challenge with this approach is the efficient delivery of siRNAs to cells. Because they're very fragile, what I have to do is package them in polymer carriers before delivering them to the cells. It's a lot like wrapping up a package before sending it through the mail system. These polymers, what they do is they protect the siRNAs and help them get to their final destination. Now, in the way of results, what I've done so far is establish the ability to silence or prevent these bone formation processes in laboratory cell cultures. What I'm doing right now is testing them in mice that have FOP to see if it can make that translation.
Notice that here Arun is using the strategies from the novelty moves again to make sure his audience stays with him. These phrases, "what I've done so far" and "what I'm doing right now," tell us the status quo of his project in relation to his overall goals. He mentions his challenges, which are like gaps, and then references how he's solving the smaller problems within his larger one. This is effective because it gives us a sense that this project, while large, is feasible and is on its way to being realized.
With some more optimization, fine-tuning, and hard work, I believe that we can mature this technology to create siRNA therapeutics for FOP patients. Thank you for your time.